In this video, we're going to talk about how to solve trigonometric equations such as this over the domain from x equals 0 to x equals 2 pi inclusive. And as we move through this problem, we're going to come across some algebraic decisions that have to be made. So let's review which of those are legal and which of those are not legal. So let's say you had this scenario where you have 2 tangent of x equals tangent of x plus 3. Folks, it is legal to move this to the other side and change this to 2 tan x minus tan x equals 3. This is a legal algebraic operation under these circumstances. So this would leave tangent of x equals 3. Similarly, if we are confronted with this situation where you have a constant times sine x equals that same constant times cosine x, it is perfectly legal to divide both sides by 2 and cancel the 2's out, cancel the constants out. And the reason is the fact that that 2 will never be equal to 0. Now, compare and contrast it to this final situation. Folks, we are not allowed to cancel both sides by sine of x. If you do this, okay, I'm demonstrating what not to do. If you divide both sides by sine of x, you're going to end up with sine of x equals 1. Folks, that's going to result in losing a solution unless you stipulate that the sine of x is not allowed to be 0. In other words, the input angle cannot be n times pi. For example, that input angle is not allowed to be 0, it's not allowed to be pi, and it's not allowed to be 2 pi. 0 times pi would give you 0. N is an integer. 0 is in fact an integer. And also of note, folks, is that when you are working with the domain of 0 to 2 pi inclusive, in your answer you include both 0 and 2 pi. So folks, what do you do when you're in this situation? You are not allowed to do this, again, unless and until you stipulate that the sine of x cannot equal 0. So what do you do in this circumstance? Well, the correct approach here is to factor. So what we're going to do is we're going to bring both sides, we're going to bring that sine x to the other side. That's going to leave us with sine squared x minus sine of x equals 0. Then we're going to pull out sine of x as a GCF. This is the correct way to approach it. So now we're going to have two solutions. One where the sine of x equals 0, and the other where we first set this factor equal to 0, and then finally we get sine of x equals 1. That is the correct way to approach it. With those rules in mind, let's proceed in solving this equation. So first we're going to change cotangent to cosine of x over sine of x times cosine x plus 1. And on this side, we're going to change secant of x to 1 over cosine of x minus 1. And we're going to leave the rest the way it is for now. Okay, folks, next we're going to try to combine these two fractions. And to do that, we're going to change 1 to cosine of x over cosine of x. Now, since these denominators are the same, we're going to go ahead and complete that subtraction of those two fractions. So we're going to end up with 1 minus cosine of x over cosine of x, like so. The other thing we're going to do is we're going to change tangent squared x to sine squared x over cosine squared x. And then we're going to throw this cosine squared x into the numerator. Okay, so that's going to yield this. Okay. The next thing we're going to do is we're going to multiply top and bottom by cosine x over here. Let's do that in red. So we're going to multiply this denominator by cosine of x and that numerator by cosine of x. All right, so that's going to yield cosine squared x over sine of x plus 1 equals cosine of x over 1 minus cosine of x. Now, here we have a decision to make. We have sine of x in the numerator and sine squared x in the denominator. If we go ahead and we cancel this and change that to sine of x and take away one of those sine of x's, and we change this to cosine squared x over sine of x, we have to stipulate that the sine of x cannot equal 0. Okay, so if you cancel out, what we ended up doing is we canceled, this is what we canceled. Okay, we canceled top and bottom. If that's true, then we have to stipulate sine of x is not equal to 0, meaning that we're going to restrict the domain, so x is not allowed to be 0, pi, or 2 pi. Okay, let's see what our final answers are. But again, we will not be able to include these in our final solutions. Okay, so now we have the same term here on both sides. So now, once we stipulated that sine of x can't equal 0, now we have cosine squared x over sine of x on both sides, so we can subtract that from both sides. So now we are left with 1 equals cosine x over 1 minus cosine of x. We're going to go ahead and cross multiply, so we're going to end up with 1 minus cosine x equals cosine of x. 1 equals 2 cosine x, or cosine x equals 1/2. Okay, if we go to our unit circle, let's make some room over here. If we go to our unit circle and try to find out where the cosine of x equals 1/2, let's do that up here. The way I teach this is short, medium, and long. So the cosine is going to refer to the x-coordinate. So the x-coordinate is going to be short, okay, right there. And that's going to work for these 2 points on the unit circle. So that x distance right there is 1/2. That's the cosine. This is going to be square root of 3 over 2. So this point right here is 1/2 comma square root of 3 over 2. I call that short. I call that long in quotes. And here you're also going to have a x-coordinate of 1/2, except now the y-coordinate is going to be negative square root of 3 over 2. So that is 60 degrees, otherwise known as pi over 3. This distance here is 60 degrees. Here at 2 pi, instead of 2 pi, in the world of 3's, we're going to be at 6 pi over 3. So this right here is going to be 1 short of 6 pi over 3, otherwise known as 5 pi over 3. And up here, that's going to be positive pi over 3. So folks, these are the solutions to this equation. So as you can see, we did not have to restrict. We didn't have to cite these as extraneous solutions because they never ended up being solutions to this equation.